The second video for today is going to look at two different examples of where the rapid repeated integration by parts can help us with some tricky integrals. This one is going to be another case of the magical reappearing integrand. And we'll see how integration by parts can lead us there. So we're going to start with taking the antiderivative of e to the 6x times the cosine of 4x in respect to x. And we're going to split our product into u and dv. Truth is, it doesn't really matter which one we use here. It'll turn out the same either way. But I'll put my e to the 6x as my u. And so my dv will be the cosine of 4x. And again, with the rapid repeated integrated by part, we can skip the dx here. And I'll just differentiate down 6e to the 6x. And I'll integrate the cosine of 4x. And I'll try it again. Differentiate one more time. 36e to the 6x. Integrate again here. Negative cosine of 4x over 4 and over 16. And you might be noticing like this doesn't seem to be getting any better. In fact, we seem to be just right back where we started. If we use our rapid repeated method and make those connections here, the product of e to the 6x times sine of 4x over 4, and then 6e to the 6x times negative cosine of 4x over 16. Remember that we're going to switch the sign on this one. Keep the original sign on the first one. And you might be thinking like, well, we're not going anywhere. We're just going in circles. And you're right. And that's what's so great about this. We've gone in a circle. Remember that the last step here, what we're really talking about here is the minus the integral of that final v du. That's what that last row is, the integral of v du. Well, if we look at what's going to be inside of this integral, the e to the 6x cosine of 4x. Sure, there's some coefficients in there, a couple of sign changes, but that's all just noise and background static. What we have is e to the 6x cosine of 4x, which is the same thing that what we started with. So if we set this up, we're going to get to that magical reappearing integrand. So let's see how it looks. The integral of e to the 6x cosine of 4x in respect to x is equal to the first product, e to the 6x sine of 4x over 4, minus negative, remember again that those two negatives cancel each other out, minus negative 36e to the 6x, sorry, not 36, 6e to the 6x cosine of 4x over 16. I can reduce that 6 over 16 while I'm at it. E to the 6x cosine of 4x. Plus the integral of my v du here, that's this last product, that's the last integral. So I will reduce that 36 over 16 to be 9 over 4, e to the 6x cosine of 4x. This time it is worth pointing out that if I do a quick negative count here, I now have 3 negatives. I had this one, the one that was already in the product, which came from when I took the antiderivative, and then when we do minus the integral, that adds a third layer of negative here, which means that this term will be negative. And here is where we have the magical reappearing integrand. E to the 6x cosine of 4x and e to the 6x cosine of 4x. They're in both places. Sorry, I need my dx here. And so what I can do is add just like we saw in the last problem, add this. And I might as well pull the 9/4 out because we can always pull a coefficient out. It makes it a little easier to think about. To both sides. And so when I finish doing that addition, I end up with one integral of e to the 6x cosine of 4x dx plus 9/4 of another integral of e to the 6x cosine of 4x dx. Well, that all adds up to 13/4 the integral of e to the 6x cosine of 4x dx. And that equals e to the 6x sine of 4x over 4 plus 3e to the 6x cosine of 4x over 8. And you might remember some little shortcut that we keep taking is wait for that plus c till the very end. Well, since I moved this integral out of the way, I'm never going to finish integrating there. I'm never going to get my plus c. So I do have to remember that there was a plus c all along. So I still need it. And then to get that by itself, I'll just multiply everything by 4/13. So the integral of e to the 6x, sorry, I'm missing an x there, cosine of 4x dx is equal to 4/13 times e to the 6x sine of 4x over 4. Well, the 4's will cancel. And the next one, and then in the next version, it's again, we're multiplying everything by 4/13, so that will 4 over 8 will reduce the 3 times, so the 3 isn't going anywhere. And then the 2 is still down there from where the 8 left us, and there's a 13 too. And that is our final answer. I'm going to do the next example in a second video. So there'll be a part 3 coming up also.